Much? 59 and 60. And I asked you just to do the ones that opened up. Is that what it was? Okay. Let's take a looky at 59 and 60, just the ones that opened up. Yay! That's why I got an extra nickel in my account. What, you got nickels? Nickel. Yeah. More time one watch, you get a nickel.
Wait, how do they actually pay you?
Kidding. Call sarcasm.
I know, but like, for something, someone
If you get paid a nickel a minute,
I think it has to be watched a certain amount of times, and they'll solicit you, the owner, because my email address is attached to it. They would solicit me saying, "Hey, this has been noticed as a popular video. We would like to put an advertisement with it. The advertisement will then pay you however times it's watched." I don't know.
if you get paid a nickel every second, and you get paid at the end of the month,
It's a lot of seconds. A lot of nickels.
so how much money do you have?
Well, there's 24 hours in a day. And let's go with a traditional month. We have 30 days. And then so you have 30 times 24, and then you got 24 times 60, because there's 60 minutes in an hour. Right? You said every minute?
Well,
Or every second?
60 seconds in every minute, and 60 minutes in every hour, yeah.
And then times 0.05, because that's how much a nickel is. Cool. All right. So it looks like, let's just go to number one. I asked you to do the ones that were just opening up, right? All right, so I'll look at number one. They gave us a picture of a parabola. Looks like it's kind of looks like this. Let's pretend I could draw straight. There's -2, -5. And, so that's kind of what the picture looks like. So let's just go through and do the questions. It asks for the domain. So my graph is going to go forever left and it's going to go forever right. Agree? So my domain is going to go from negative infinity to positive infinity. That just means we can put any number in and get a number out. Then my range, the range is a little bit different because this is like an elevator going up and down. So this is where you start seeing the graph. So from -5, and I'm using a square bracket because we include that point, to infinity is our range. And then it says the max or minimum value. So we have a minimum value on here, and our minimum value is -5 because our lowest point in the y direction is -5. And then it says, hey, do we have these roots? Okay. It does indeed cross the x-axis, but when you look close enough to it, we're just kind of thinking that we don't see exact answers. Okay, though we know it crosses the x-axis, we can't see an exact answer at this point. And then the vertex as an ordered pair. Okay, so the vertex is -2, -5. So that's sometimes they refer to the vertex of parabolas as a turning point. And then the axis of symmetry, we'll call that AOS, is going to be x equals the x component of the vertex. So that would be this vertical line that we'd be symmetric about. Let's see. Interval where it's increasing. Okay. Increasing. So again, increasing means if I were to take any 2 points on one side or the other, if I found the slope, I mean, honestly, my slope equation is y2 minus y1 over x2 minus x1. We would have a positive slope. So it starts here, it's an open dot, and it goes forever this way. That's where it's increasing. So from -2 to infinity, the graph will continue to increase forever. And then interval where f at x is positive. Okay, So we want to know where f at x is positive. Well, we have to realize that f at x is another name for y. So where is y positive? It's positive here, and it's positive here. So so this is coming from negative infinity. We're going to talk about in the x direction where it's positive, up until whatever that point is. But look close enough, I might be able to see that point's like negative 4.2 roughly. Okay, so that's about right there. And then if I look close enough, this one looks like it's about 0.5. So it goes from 0.5 to infinity. So the ones that are a little tougher to decipher, I think the domain all day long, you're going to nail. I think the range, if you're paying attention, is not quite as tough. I think you can figure it out, definitely. Hey. The minimum, again, if you're paying attention, I think you could figure that out. The roots, if you're just looking at the graph, or you are able to find the equation of factor, I think you do that. The vertex, I think, should be a gimme. And the axis symmetry should be a gimme as well. Increasing, a little bit tougher to kind of fathom. And then where the things are positive, I think that's a tougher one to figure out as well. Okay, but like these kind of problems, when we have them on a test or quiz, each blank is worth 1 point. So even if you can't do one or two of them, should you leave the whole thing blank?
No.
No, get all the points you can. Yeah.
Wait, okay, so when it says if fx is positive,
That means that where is our graph above the x-axis?
is it above the x-axis? Or where?
So this is the x-axis, right? Like that?
Yeah.
So on the left side and on the right side, this stuff in the middle here, we'd have negative y values. Over here I have a positive y value, and over here I have a positive y value. Because in the y direction it's above, counting upward.
So what would my answer be?
For where's it positive? Negative infinity to 4.2, we're across the x-axis, and then from about 0.5 to infinity. So that lower left-hand corner.
Oh.
Okay. Okay. So let's try another one. Number 3 also opened up, agree? So let's just take a look at that one. So if I look at this, it looks like we have at 1, 0, we have this taking place. Agree? Okay, so talk to me. What is the domain? What was the domain on the last one?
Negative.
Negative to positive infinity. So the domain of this one has to be the same. Okay, and again, our parabolas, our domain in this class will pretty much always be that. I can't think of a situation where I'm going to change the domain on you on a parabola. Okay, my range. So what is my smallest y value up there? 0. And then it's going up. So my range is going to go from a square bracket at 0 to infinity. So it's going from this up. And we include it, and that's why we have a square bracket there.
If it was going down, would it be square?
So we will do one of them. It will be a square bracket, but it'll go from negative infinity up to whatever that is.
Oh.
Well, I'll do one. I didn't ask you to do it, but we'll look at one. Min or max. Well, this is a minimum, and our minimum value is at 8. So when you're asking about minimum and maximums, you're talking about where is the x, or where's the y? What's the lowest y or the highest y? And then roots. So that's a 0 right there. So roots, I actually only have one root. I have 1, 0. Does anyone know what happens if I were to factor this out, what that means? This would have been one of those, would have been like x minus 1 and x minus 1. You get the exact same thing when you factor it out. And it's called the double root. It happens twice there. Christian, you have a question?
Is that minimum 8 or 0?
That's a 0. I've just written over it too many times now. That's got goofy on me. Okay. Oh!
Yeah.
Thank you. Couldn't read my own writing. Thank you. That should be a 0. Good job. Good job. I see what happens when I try and make things nice and neat. So we have the roots vertex. We have the vertex. The vertex is 1, 0. Our axis of symmetry, which we'll call AOS, is x equals 1. So it's this vertical line right here. Our interval where it's increasing. Increasing. So the vertex is the turning point. So is it increasing on the right side of the vertex or the left side of the vertex? Where's this increasing? Right or left side of the vertex?
Right.
The right side? So it's increasing over here. So it goes from here over. So from 1, rounded bracket, because it doesn't equal 1, to infinity. That's where it's increasing. And then, you what? And then the interval where it's positive. So this is a little bit of a gotcha problem. Every point's going to work except for 1. Which point do you think won't work up there where it's positive, where it is above the x-axis? What happens at 1? What do I get? What is 1? It hits the vertex. So 1 hits the x-axis. It's at 1, 0. So at 1, 0 is a 0. Is a 0 a positive number? No. So it's positive from negative infinity up until I get to 1, rounded bracket. And then at 1, it's going to go to infinity. The rounded brackets at the 1 and the 1 mean I'm not including the 1. I'm going right up to that 1 as close as I can get from the left and as close as I can get to the right, but I'm not going to include it. So you actually bound it like that. There was one more on the back page. Is that right? 2 more? Both opening up? Oh, I have 2 that open up. Okay. Number 5. Okay, so it looks like that. So the domain, who wants to take a shot at the domain?
Infinity.
Yeah, negative to positive infinity all day long. The range, where does it start in y direction? Three, cool. So starting at 3, square bracket to infinity, it's going to continue to grow. The min or max, well, we have a minimum. So what's my minimum value? 3, cool. And then roots. Okay, now this one's going to be a little bit different on the roots. Looking at this picture, you see where the graph is. Will this graph cross the x-axis? No, we're seeing all the changing of directions right there. So the roots are actually, we're going to label them as complex. And what this means is if I had tried to solve this problem, I would get x equals a negative square root. A number underneath the square root of a square root sign with a negative number underneath it. It becomes something called an imaginary number, which is part of the complex number system. But we'll get to that a little bit later too. Roots, vertex, we can do that. What's vertex? Huh? 0, 3. Okay. Let's see, vertex. Axis of symmetry, we'll call it AOS. What's the axis of symmetry? 0. It's the x component of the vertex. So it's this. That's my axis of symmetry. Interval where it's increasing. Is it increasing on the right or the left side of the vertex? Right or left side? On the right. So on the right, so from 0 to infinity. And the reason that is if I were to pick this point and this point, and I plug those into our slope equation, if I had done that, pick any 2 points on this side, the slope is positive. So from 0 to infinity, it's increasing. So all over here is increasing. That's an open dot there. We don't include that. And then the last one says, where is this positive? So where is our graph above the x-axis? The whole time. So that's got to be negative to positive infinity. It didn't cross the x-axis or touch it. So this one is a negative to positive infinity. Or it's positive. Positive means that the y values are all positive numbers. And then number 6 is the last one we had to work on, right? Number 6. That looks like this. I'd say 1, 2, 3, 4, -1, 4, -1. It's right there. Then definitely 1, 2, 3. Got a dot there, and I got a dot there. Okay. Quick, domain. Negative, positive, infinity. Range, where's the smallest y value? -1. So from -1 to infinity. Is that a maximum or a min value? It's a max? It's a min. It's the lowest point. So it's minimum value. The y component of my minimum value is -1, so that's what we're looking for. Roots. Yeah, I got 2 of them here. So that's the point 3, 0. The other one's the point 1, 2, 3, 4, 5, 0. There's my roots. Well, that's pretty cool. Finally got some roots that we can deal with. Vertex. 4, -1. Good. Axis of symmetry that we'll call AOS. X equals 4. So make sure you have the X in there because it's a vertical line. Interval where it's increasing. So is it increasing on the right side of the vertex or the left side? On the right. So it's increasing over here. So it's going to go from 1, 2, 3, 4. So from 4 to infinity, increasing. And then where is my graph positive? Is there one region that's positive? Are there 2 regions that's positive? Are there 3 regions? Are there none? There's 2. So it's positive here, right up to that point there. And it's positive there. So it's positive from negative infinity, coming this way, all the way to 3. Rounded bracket, because exactly at 3 it's 0. And then it's right there. So from 5 to infinity, that's where we have our graph being positive. Huh. Feel all right? Okay, look at the rancher problem. You won't have to turn the rancher problem into me, but just take a look at it. It's on the next page, page 61. It says a rancher is building a rectangular corral for her horses. So like a pen, place to put the horses. She can afford to build 300 feet of fencing, but wants the area of the corral to be as large as possible. So she has 300 feet of this fencing that she could make it as, just 300 feet long, or, start making it into a rectangle of some sort. The graph below describes the area of the corral in terms of its width. So it looks like there's a point there that's 30, 3600. There's the vertex, which appears to be 75, 5625. Okay, so what is the vertex of this function? Well, the vertex is at 75, 5625. And what does it mean in the context of the problem? That means that if you had a width of your rectangle being 75 feet, okay, so you have to figure out what your length would be, but if you had a width of 75 feet, so you had a 75 foot and a 75 foot, and then the rest of the fence made up the rest of it, we would enclose an area of 5,625 feet. That's the maximum amount of square feet that my pen can be. And the reason it's a max is that parabola opens downward. And then the point 30, 3,600 on the graph, what does that point mean in the context of the problem? Well, that means if I made my fence have a width of 30 feet, so I had a 30 foot and a 30 foot section as two of the sides of my rectangle, then I would have an area of 3,600 square feet. Okay? And I want you to know something. What does it say at the bottom of page 61?
Link to videos for answers.
So if you type that in, I don't have the answers to this in the back of the book. If you go to the video, I think I made all of them about 5 or 6 minutes in length for all the answers of this whole section, which is kind of cool. So we were just trying that with you guys to see if that would work out for you. Okay? So if you would, make sure your name is on, and you can turn in page 59 and 60. Don't worry about that last page. Just turn in 59 and 60. And if you're turning anything else in, please, by all means, hand that up forward as well. Okay, get my notes. I forgot my notes. Mr. Boyd, will you collect the homework to you?
Pick it up. I knew someone was gonna say that. No, I was This just in. Local walrus stealing from zoo.
Really? Walrus is stolen from the zoo?
No, I'm joking.
I like it.
Let's go with Tom help you.
Hi, Jesse. I'm here with the balloon.
Would you like my voice now? No.
Okay. Tomorrow, me and I have yet to miss school for any time for me. I missed for the cadaver lab first semester, but it was still school related, so I wasn't really missing school. I was missing these classes. And but I have a sub tomorrow. Her name is Mrs. Hogue. She is a former math teacher here. Just gotta give you a heads up. Please be good for the sub. No, she's awesome. She's an incredible teacher. She's just a retired teacher, but she comes in, she's just subs for us here at Creek for the math department. So she has an activity that you guys will be working on in class. Ask her anything. She's a heck of a better teacher than I am. So she's pretty incredible. But just please be aware that I take it as a personal insult to me, and I feel it's an attack on me if I get a bad report from a sub. Okay, so please, be on your best behavior. Does she have the same policies as me? Probably not. You might have to ask to use the restroom with her. As far as cell phones go, I know I've gotten a little more lenient, but you might want to just kind of keep them to a minimum because she might be the one who takes it from you and turns it into the dean. I don't know. But I just want to give you a heads up. So please be good for the sub, out of respect for me. I get it sometimes when you have a sub. I know it's not your normal teacher, so your routine's a little goofed up. But she just has an activity that you guys are going to be working on. And this is actually goes along with what we're teaching today. Okay? So I'm just taking a personal day. Nothing wrong. I'm just taking a day. Day for me.
That's good.
Is that all right?
Are you going skiing?
You did
Oh,
good.
heck yeah. Heck yeah. And you know how many people are skiing on a Tuesday? Very few.
Yeah,
You deserve it.
makes sense.
I'll have front row parking.
And then you're gonna drive to the springs out there, yeah.
Why would I drive this spring?
Close to the hot springs. Or...
Oh, I thought you were meaning Colorado Springs. I'm like,
No,
I don't
no.
want to go down to the armpit down there.
No.
I can't speak slow enough to the people down there.
Woo! Roasted in a tiny section.
So kid, I'm from the Springs. I know. I got to talk real slow to you too. All right. So this what I'm going to show you all today, I'm a little embarrassed to say that I'd been teaching for a very long time before I became aware of this rule. You know, like a lot of times when I taught quadratics, it was just like, oh, you have to do this, plug points in, this and that. And this rule is fantastic. It shows an awful lot, and it works so well when graphing parabolas. So let's look at the second slide. And notice this. It says, hey, we want us to find the slope. And you're like, why do I have to find the slope? It's like so first semester. You're totally right. But you remember this. Doesn't this look like the slope equation here? Usually it says m equals. But then we have to remember we label x1, y1, x2, y2. It doesn't matter the order you do. Just don't mix x1 and y2 together. And you plug those values in, and you get 5 minus 3 over, so 5 minus 3 over 2 minus 1. And 5 minus 3 is 2. 2 minus 1 is 1. So I get a slope of 2. Now let me ask you this. Is 2 a positive number?
Yeah.
So is this an increasing slope?
Yeah.
Yes. Okay, and that's exactly what I mean. So like 1 comma 3 is right here. And then 2 comma 5 is here. So, you know, is the slope between those increasing? Yes, it is. It's a positive slope. And that's really what we're doing a lot of times when we're saying, hey, where's it increasing? That's the math practice that we technically are going, but we can recognize by looking at the graph, you know, it's an increasing function. Okay? So, I'm not doing this. No groups. We're doing it as a class. Okay. Doing this as a class. All right. So, slopes. Slopes. If you have x squared, what is my a value out right here? 1. So if I have a 1 out front, you're going to graph, once you find the vertex, you're going to graph by the 1, 3, 5, 7, 9, all the odd numbers rule. If your a value is something other than 1, then you're going to multiply that a value times the 1, 3, 5, 7, 9, keeps going. It's all the odd numbers. Okay? So let's keep that in mind as we progress a little further. Okay, so we want to find our 4 points. We want to find the vertex, y-intercept, and roots. Okay, so there's the one equation. That's our go-to. What is our go-to on this equation? I think Sophia knows it really well.
I low-key forgot it. Was
Negative.
it negative B?
Negative b over?
2A.
Negative b over 2a. That's it.
Sorry.
That's it. And then up here on my graph, I know that my a value is 1, my b value is -4, and my c value is 3. And we haven't really been working a lot with the c value, but it's okay to label. We'll see it later. So I'm going to get -4, because there was a negative and a negative there, over 2 times my a value. What's -4?
Positive 4.
Positive 4, and that's going to be over 2. And what's 4 over 2?
2.
2. So x equals 2, that's actually my axis of symmetry. So x equals 2 is my axis of symmetry.
1, 2, 3, 4.
Yay. So that's my axis of symmetry. So my vertex will fall on that. So let's find the rest of my vertex. So I know that I have 2 comma, how do I find the rest of my vertex? Forget.
Plug it into the
Plug it into your x value. So 2 squared is 4. And then 4 times -2 is -8. And then plus 3. So 4 minus 8 is -4. -4 plus 3 is -1. So 2, -1 is right there. Is that okay? Now, Are you ready to see butter?
Pure milk.
This is the coolest concept. So does everyone feel pretty much okay finding that vertex? Is anyone like, dude, where'd that point come from? Good, we didn't hear that yet. All right, so you remember that 1, 3, 5, 7 that we talked about? You don't have to use all of them, but that's how things are going to grow with a parabola. Okay? So, from my vertex, I could fold it over the axis of symmetry and becomes symmetric. The graph falls right on top of itself, right? So, is my A value up there 1?
Yes.
A value is 1, so 1, 3, 5, 7 is going to work. We don't have to use them all. So watch this. Ready? From my vertex, I'm going to go right 1, up 1, left 1, up 1. Okay, so far? From my new points, I'm going to go right 1, up 3, left 1, up 3. And I could keep going. I have enough room to do it. So from my new points, I'm going to go right 1, up 5, and left 1, up 5. Look at this parabola. Friends,
It works that way every time.
okay? If you note what your A value is, if your A value is not negative, or if it's a 1, it's going to work like that every time. Do we have identified a whole lot of points? Yeah. I mean, I could say, oh, that's my vertex. My vertex is at 2, 1. My roots are at 3, 0, and 1, 0. This point here is at 4, 3. This is at 0, 3. This point here is at 1, 2, 3, 4, 5, 8. And this one is at negative 1, 8. I got all kinds of points I just identified because pattern graphing works, and it's that cool. Okay, we can definitely see our roots because we can see exactly where it crosses the x-axis. My roots up here would be 1, 0 and 3, 0. Y-intercept is right there. Cool, let's move to another one. Okay, is this parabola going to open up or down?
Down.
Down, why is that?
Because it's a negative.
I have a negative out front, okay? So I'm going to use my x equals negative b over 2a. Over 2a. And I know my a value is negative 3, my b value is 12, and my c value is negative 9. So let's plug our values in. So I get negative 12 over 2 times negative 3. So that's negative 12 over negative 6. And a negative over negative is positive, and 12 over 6 is what? 2? Positive 2, right? So that's my axis of symmetry. It's at 2. Okay? Let's find the rest of my vertex. So I know I'm at 2, something. How do I find the something? Plug it in. So I get 2 squared, that's 4. 4 times negative 3 is negative 12. Is that okay so far? Then 12 times 2 is 24 minus 9. So negative 12 added to 24 is 12. 12 minus 9 is 3. So I get 2, 3. 2, 3. Okay?
Why is 12 negative?
Because you always have that negative out front. It's a constant.
Oh.
Okay? That's all right. All right. So my pattern graph is going to be a smidge different. It's a smidge different because my A value is what? It's negative 3. So it's going to be negative 3 times 1, 3, 5, etc. So it's usually going to be my A value times 1, 3, 5. Okay, so that's going to give me negative 3 because 3 times negative 1. 3 times 3, negative 3 times 3 is negative 9, and then negative 15. Now some of these, this is going to grow pretty quickly in the negative direction, so it's probably going to go off our graph pretty quickly. But for my graph, it's still going to be the same thing. Ready? Right 1 and down 1, 2, 3. Left 1 and down 1, 2, 3. Why did it go down 3? Well, it's negative, and my A value happened to be a 3, a negative 3. Okay? So my next point, I'm going to go right 1 and left 1 from my red dots down how many? 9. Yeah. So I'm going to go right 1 down 9. And I'm going to go left 1 down 9. And that's about as many dots as I can squeeze into this one. Just like that. Could I identify what those dots are? Sure. They're whole numbers. Do I see my roots? Yeah, in this case I do. I have a root at 1, 0 and at 3, 0. Where's across the y-axis at 0, -9? It's all right there. So we just did one that opens down, and we did one that opened up. And that 1, 3, 5 rule works as long as we realize we have to multiply the a value to it. It's still always going to be right 1 and left 1. That's what's going to take place. Good? All right. Cool. Hey, I got done. So, I would like for us to do page 63 and 64. Now you'll notice something on 63. You don't have the problems, so your homework's really only 64. Okay, so there's 6 problems to graph. Okay, I'm going to ask Mrs. Hogue to go over all 6 of those problems tomorrow with pattern graphing, and then you're going to just have an activity to work on pattern graphing for tomorrow. Do me a favor though, folks. Do me this big favor. Don't hand anything in to the sub. Okay, I don't care if you have some late homework from 16 years ago. Here I colored my name. Don't hand it in tomorrow. Don't hand it to the sub tomorrow. Okay, deal? Will y'all do me a big favor and be awesome for the sub?
Of course.
Please don't get a bad report. If your name gets named to me by the sub, I turn it over to your dean, and your dean makes fun of you, shaves your eyebrows off, and then makes you eat hot sauce through your ears.
And then I'll blame it on you, Mrs. Sterling.
Yeah, there's nothing to do there. Yeah, there is nothing on page 63 for you to do because I didn't give you the equation. Cool? Everyone good?